Hi all, here we will quickly review the periodic table and classifying the elements. Remember that the periodic table is arranged in a very specific way. It's not just that shape just for fun. Every eighth element, we repeat the pattern. Remember, that's called periodicity. It's periodic trends. That's what this whole chapter has been about, and it's what we'll talk about in the next section. So every time we go through 8 elements, they repeat oneself. So that's why ones that are in the same group or column on the periodic table they all have similar properties. And so we classify and name them based on their group. So if we look at the periodic table, this is what you typically see. We see the number on the top, that's our atomic number. That tells us how many protons are there. Then we have the symbol, the name, and their atomic mass. The valence electrons are the ones that are in the outer shell of electrons. These are the valence electrons are the ones that are involved in bonding. So in ionic bonding, there's a complete transfer. There's a loss or a gain of valence electrons. Whereas when we look at covalent bonding, we see those valence electrons being shared. So the valence electrons are some of the most important. All right, so here we have our groups that we're going to talk about. And the most important things I just want to touch on is their names and how many valence electrons and what ion they form. So group 1 or 1A, these are our alkali metals. They are the most reactive metals on the periodic table. You know that when we drop these into water in class, they catch on fire and explode. Group 1 always has 1 valence electron, so 1 in the outer shell. And typically they're going to lose that electron to form a 1+ ion. Remember that the reason that ions form is because elements want to have a full outer shell. So they're either going to lose one so that their next lower shell is full, or they're going to try to gain some to fill their shell. So the left side of the periodic table, or all metals, are losers. They lose their valence electrons, while the nonmetals on the right-hand side gain. So group 2, they have 2 valence electrons. These are known as the alkaline earth metals. They are a little bit less reactive. You can see from the picture that some of them can be exposed to air. Well, if we look at this slide here, the alkali metals all have to be stored under oil. These guys lose 2 electrons to form 2+ ions. Once we get to the transition metals, we have to realize that we cannot just predict all of the time what their valence electrons will be because they're different. So remember, we have things like copper 1 and copper 2, and I call those Roman numerals their last names. And that's because it helps us demarcate between the two. So if you ever just tell me, oh, I'm working with copper oxide, that's not specific. I don't know what you're talking about. Is that copper 1 oxide, copper 2 oxide? Because those two things behave very differently. So you have to include that Roman numeral, and that Roman numeral tells you the charge. Copper 1 means it has lost 1 valence electron, so copper +1. Copper 2 means that it has lost 2 valence electrons, forming copper 2+. The transition metals are not very reactive. They're also known as the D-block elements. We jump all the way over to the other side of the periodic table, and we talk about the halogens, which are group 17, also known as 7A. They have 7 valence electrons. Now, remember that elements want to have 8. So, since it has 7, it's going to gain 1 electron. It's easier to gain 1 than it is to lose all 7 to fill that shell. So, since they gain 1, they're going to form 1- ions. I want to backtrack a little bit. Group 16 or 6A, they're going to gain 2 electrons, so form 2- ions. And group 15 or 5A, they're going to gain 3 valence electrons, so they'll be 3- ions. And again, remember that since these are the halogens, the whole group or the whole column all have similar properties. The last group we're going to discuss is the noble gases. They all have 8 valence electrons, which is a stable octet, except for helium. Helium only has 2. The reason it only has 2 is because that first shell or energy level of electrons can only house 2 electrons. They do not form ions because they're happy with all 8 electrons. They don't want to gain or lose anymore. They're happy where they're at, which means that they're unreactive and they're inert. Last guy we'll talk about is hydrogen. He's not officially a part of any group, although he would be considered as part of the nonmetals. It is a gas at room temperature, STP, standard temperature and pressure, and he has 1 valence electron. So hydrogen is a part of group 1, but it is not an alkali metal.